this is a nice one. So they have an environmental disaster. They have an environmental disaster. Environmental disaster threatens the small town of Bafanaville. I wonder where is Bafanaville. Bafana threatens the small town of Bafanaville, and then this is the natural disaster. There has been a large spillage. Remember, when we talk about spillage is when something accidentally falls in or where it's not supposed to. Spillage of concentrated hydrochloric acid, which is HCl, hydrochloric acid, into, and this is into the town's water storage. Oh, now we've got HCl. Now we already know that it's hydrochloric acid. How do I know that it's an acid? Remember what Arenas and Lowry Brownstead tells us. It will donate the H plus to form H3O plus ions in solution. And that's then how we know that it's an acid. Right. So now it tells us here, we need to explain with the aid of equation. Oh, and no, I didn't write the whole question. In the count storage dam, the final sentence. The pH, already if you see pH, you think of H3O plus. The pH of the water has decreased to 4. Now, I want us to actually elaborate on this. Remember, if we have hydrochloric acid, it is an acid. An acid will lie. Let me just look for one of my nice diagrams again. If this is an acid, it will lie between 0 and 7. Now, they're telling us Bafanaville had a big problem and something spilled, and now they have, so maybe it was somewhere there, and it decreased all the way, if hypothetically speaking, if that was 4, it decreased up to 4. Now you can already see, dun, 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 it moved more to 0, making it very, very acidic, making it more acidic. So now the first question says we need to explain with the aid of an equation. I actually like the ones with an equation other than words. With an equation, why the pH, but I'm going to do both with you guys, why the pH of the dam water decreased. Okay, I want to explain it first. Remember what I said. Hydrochloric acid is an acid, and they told us that it moved closer to 4. It moved to 4. If something moves closer to 0, if it's close to 0, it means it's becoming more and more and more acidic. So the water in Bafanaville's dam is becoming more acidic. So how would you explain that? Spilling the HCl means that the pH dropped, because when pH gets closer to 0, it's indicating that it's becoming more acidic. Because if it was moving further and further away from 0 towards a 7, it means it's becoming more neutral, which is the normal pH where we want most of our things to be. But if it's going towards the 0, if it decreases to 0, it's becoming more acidic, and that's how we know. Think about the pH scale that I showed you. Now, before we do an equation, what do we say about acids? Arrhenius' theory and the Lowry-Brownstead theory identifies or explains an acid and an acid. The one says an acid will donate an H plus and it will form H3O plus in water. So an increase of the H3O plus means it is more acidic, right? Now let's see if we can have this reaction. So if we have HCl, and we are adding this to water, to H2O. Now, what happens? Because HCl is an acid, it will donate an H plus, and it will have a Cl minus. This H will come and embed itself in the water to form a hydronium. So I'm going to have Cl minus plus, this H plus will come to the water, making it an H3O plus. Make sure that you don't forget your charges. So this is how this reaction will be. According to the Lowry-Brown state theory, an increase in this shows that it is acidic, right? Let's assume I'm going to write it down. Arrhenius, and here he says acids. He says acids form H3O plus. So if it didn't form H3O plus, it wasn't an acid. And when do they form an H3O plus? When dissolved in water. So this means that an increase of this, and remember, if you have a pH is negative log and the concentration of H3O plus, an increase in this will decrease your pH, right? I want you guys to look at that. An increase in that means if I have more and more of the H3 pluses in the water, it means it will decrease the pH of the water in the dam. And how do you know this, Tops? Is because if I look at Arrhenius' theory, he's the one who said acids will form H3 plus when they are dissolved in water. So that was not very tricky. That was actually for only 1 point. So then the municipality decides to come in and actually do something for this for Bafanaville. So it says the municipality decides to add quantities of soda ash, which is Na2CO3, to the water of the dam, hoping that the pH will restore to a volume closer to 7. Dun, 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 dun. What are we doing? HCl is an acid. We're adding soda ash, which is a base. They are trying to get it closer to 7, which they are trying to neutralize it. So already if you hear acid base in a solution trying to neutralize, you must have your light bulbs going on. You must think titration. So let's see. So now we need to calculate. So I'm just going to write this question, but the municipality is adding some soda ash, but we need to calculate the mass of soda ash. The mass of soda ash, and soda ash is Na2CO3. Soda ash required to neutralize each. Ooh, this is actually a very tricky one. To neutralize each 1 cubic decimeter of the acidified. So they're using 1 cubic decimeter because we don't know how much water is actually in the dam or the volume of the dam. Acidified dam water. Okay, so now we're actually going to work backwards again because remember, they told us that the pH decreased to 4. So our pH is already given to us. It's 4. What is this bringing to you? What we did on this side. On this side, we were actually given the pH and we had to work backwards, right? So it's the same thing we're going to do here. In this one, they told us that the pH decreased to 4. So now we're going to work backwards. Let's use blue. So now I know that my pH is 4, right? And if you have pH is equal to negative log and the concentration of H3O plus, the pH is 4, negative log concentration of H3O plus. Remember what I taught you in the previous slide? The easiest way to remember this, you write the concentration of H3O plus, and you're gonna write the 10, and you remember it's negative pH, but in this case I know that my pH is 4. So now the concentration of the H3O will then be 10 to the negative 4. Well, another way you can look at it, if you have C is equal to N over V, and they've given us the volume of as 1 cubic decimeter, right? For a volume, if the volume is 1 dm 3, then it means for every 1 cubic decimeter, the moles will then be 10 to the 4, right? Or you can use the XY one that I actually showed you before. But now let's answer this question. We need to calculate the mass of soda ash that was used. I'm going to rewrite the equation again. I just want to remove this so I can work here. So the equation, I have HCl, which is AQ, plus Na2CO3. Now, in this case, they didn't actually give us the reaction, but I'm going to show you how we do it. Remember, when you have CO3, always think carbon dioxide, carbon dioxide. You must have a button that's ringing. Remember, before you get a salt and a water if it's an acid and a base. But you have CO3, you must have CO2 as carbon dioxide, you must have a water, and you must have a salt. So instead of having 2 things, you will have 3 things at the end of the reaction. You're going to have a salt, you're going to have a water, and you're going to have CO2. So let's see, I'm going to write my water as H2O. How do you get your salt? See what you're going to have. This H went to the water, so I'm going to have sodium chloride. I'm going to have Na and Cl. NaCl. Already this means this is not balanced. Let's see if we can balance it. I've got 1 hydrogen here. I've got 2 hydrogens there, so I must put a 2 there. I've got Na2A. Let me see. I've got 2 Nas there. I've only got 1 there. I'm going to put a 2 there. And then my equation is balanced. My mole ratio is mole ratio of 1:1. So I need to calculate the mass. Mass means a small m. Where do you get the small m? I'm going to work here. If you have N is equal to m over big M. So at the end of it all, I must end up with that. So let's see what we actually get. So now I actually have my concentration, which is, let me write it as 1 times 10 to the 3, and that is for my hydrochloric acid. It's a ratio of 2:1. So if 1 mole is 1 times, if the concentration rather is 1 to the negative 4, I must divide that by 2 to get the concentration of 1 mole. Let's see what we get when we work that out. So in my calculator, I'm going to have 1 times 10 to the exponent negative 4, and I want the 1 for 1 mole. So I'm going to have 5 times 10 to the negative 5. So I'm going to have 5 times 10 to the negative 5. So then there I have my 1 mole, which is 5 times 10 to the negative 5. Let me just use another color, but I'm not done. Now I'm going to use the formula, because remember, I've got more information for the NCl, but they want the mass for the soda ash, right? For the soda ash, they want me to give the mass. They've given me the moles. I just found out the moles now, which I just worked out as 5 times 10 to the negative 5. And then let's see. If I now have N is equal to small m over big M, I found my moles as 5 times 10 to the negative 5. I am looking for the big M. Now I need to calculate the big M. Let me work it out here. So if you have Na2CO3 for soda ash, I'm going to look for the molar mass, which is 2 Na plus 1 carbon plus 3 oxygens. Now I'm getting these values on my periodic table. Na is sodium. It has a mass of 23 plus carbon, which has a mass of 12 plus 3, and oxygen has a mass of 16. This will give me 46 plus 12 plus 6 times 3 is 8, carry 1, so that's 48. So I'm going to get, okay, my maths is not that good. See, I'm going to have 46 plus 12 plus 48 will give me 106. So my big M is 106 grams, which is 106. Now I want M to stand by itself. I'm going to cross multiply. I'm going to have M is equal to 5 times 10 negative 5. Multiply all of that by 0.6. Let's see what we get for the mass. Oopsie daisy. See what we get for the mass. I'm going to say bracket 5 times 10 to the exponent negative 5. Take that down, and that's 106. I get 5.3. get 5.3 times 10 to the negative 3. I get 5,3 times 10 to the negative 3 grams. And this is of soda ash, which is Na2CO3. How did we get this? Let's just recap on that. We were given the pH, and they told us that the pH of this solution is 4. Usually we have to look for the pH, but we have to work backwards. We know for us to find the pH of the solution, we first have to find the concentration of the H3O+. What did we do? We worked backwards. We then found the concentration of the H3O+, and this was the concentration of the HCl. And then we used our mole ratios to help us find the next move. Remember, it's a mole ratio of 2:1 and invisible 1. If the mole ratio of the HCl is 1 times 10 to the negative 4, the mole for 1 will be 5 times 10 to the negative 5. And then I had to find the big M for my soda ash, which is the 106 rather. I'm looking for the mass, and then I also had the moles, and then that is then how I found my answer.